Okay, so now we're going to move into still looking at these recurrence relations, so those sequences, but we're going to put the financial rules in there. So the first ones we're looking at, so we're going to look at some modelling. Modelling just means so when we're using these practical applications. So we're using the financial part, and the first ones we're looking at are linear growth and decay. So what this means, when you've got linear growth, it actually means it's going up it's always a same amount. So if it's growth, it's you're adding the same amount. If it's decay, you would be subtracting the same amount. And so they're examples of things like that are simple interest. So when you do simple interest in finance, what you do is you find the percentage of the original amount. So say I had $1,000 and I said you get 10% simple interest. That would be $100 that you're adding on every time. It never changes. It's always adding on 100. And if it was linear decay, which is like flat rate, it would be something is depreciating, getting less value by the same amount every time. So if it was reducing by $20 every time, it's the same amount. So that's what linear is. Later on we'll look at the other version, which is geometric. So first of all, so we're going to look at, now it just says there, under there, it is a straight line. So if you have, I'll just draw them underneath. If you have linear growth, you've got a straight line. If you were graphing, so in terms of the value after each term, you will see it grows up in a straight line if you were doing that. If you've got linear decay, so something's depreciating, means it's going down in value, you'll see that if you plotted the value over each term, you see this, you get this straight line like that going downwards. Okay, so we've got, so linear growth in a quantity equals a quantity in a sequence increases by the same amount. So this same amount here and that we're talking about is actually this D in the recurrence relation. So if you look here, we've got this is a recurrence relation there, rule. So this is the rule that you're always adding. So with my example I used before, I was saying that we had, say we had a beginning of $1,000, remember? And then I said you got 10% interest. So the way I was adding what was I saying? $100 every time. That would be that example of linear. Linear decay, it's the same, you'll see the same amount being reduced, and there it is. So the minus the D. All right. So as I said, simple interest is an example of linear growth. So we've got simple interest. So let's have a look. So simple interest is a fixed amount of interest that is paid at a regular interval. So it depends if you're getting monthly interest, yearly interest, but it will always be the same amount every time. So say every year we were adding $100. Now the principle, so we're starting to talk a little bit about finance. So they'll often say when you're doing a simple interest, you've got an investment, and they'll say you begin with an original amount. So the original amount in financial language is called principal. So for us, that's going to become our VO, our original amount in our finance recursion formula. And the amount added usually is a percentage of the principal, which we're just going to have a look if I flick on to the next page. So here is a recurrence relation of, this is simple interest formula. So here we know we're going to use our VO for the principal, and this is going to be the interest that's getting, this is the interest that's getting added on. So the interest added on. Okay, now we need to have a way to work out what that adding on amount is, and we've shown you how you can work it out here. So how can I work out this D? I can use that. So I use the rate divided by 100. So if they say, say for example, you've got, I might say, you're starting off with we said $1,000, and I might say the rate I said was 10% per annum. So if I look here and I was trying to work out the D, I'd go D equals the rate 10 over 100 times VO, so times 1,000. So that's what I did to get the 100. So I'm adding the 100. So that's what I'm doing in that example that I've been talking about. All right, sometimes you'll get asked to find certain amounts. So if you have to find the interest, we can use the rate times the original amount. If you're asked, so things like that. This might come in handy a bit later on. So just don't worry too much about this bit here, but I've put it in there. And here we go. Here's our straight line. Simple interest will be a straight line up there. Okay, so this is a graphical representation of simple interest. All right, so let's do a couple of examples here. So Michael gets a loan from the bank for $7,000. So what I'm going to show you now is I'm going to start showing you how you approach these questions when you're in your exam and things. So he gets a loan for the bank of $7,000. So I know that's the original amount. So it is the principal, but we are calling it VO. So you might start writing VO above it for you. And it's at a simple interest. This becomes really important too. We always want to know what we're talking about. They will tell you. So as soon as you know simple interest, we know to move to our simple interest rules. And they've told me that it's 7.4% per annum. So they're giving me the R. Okay, it says model this recurrence relation using, you can hardly see that, but Vn plus 1 and Vn. So we know, it's just, you write a recurrence relation for this. So if we write a recurrence relation, we have to write VO. So I write VO, which is 7,000, and then I have to write a rule, the Vn plus 1. Now, if I've gone to my simple interest formula and I know that I have to do it's something like this. It's this pattern for simple interest, but I need to, maybe on the side, I'll have to calculate what D is. Now remember, D is the rate over 100 times VO. So I'm saying that the rate is 7.4 over 100 times VO, which is 7,000, and we end up with 518. So there's how I found. So I can finish off my recurrence relation here and actually write it in as plus 518. Okay, so you need these two things to get your marks for the recurrence relation. All right, so part B, it says use the recurrence relation to find the value of the loan after 1, 2, 3 years. So this is where you just do it in the calculator, just follow this method. We don't need to worry about that other way. So here I would pop in the 7,000 into the calculator, press enter, then you get answer. We would say answer plus 518, and we get 7,518, and just then press enter and get your, it says 1, 2 and 3 years. So this is the beginning. So this is not 1 year, this is 1 year, and then you do over here. So we've got 1, 2, 3. The third year ends up being 8,554. Okay, now it says use the calculator to determine how many weeks it would take the loan to be more than 10,000. So you are already up to 3 years with 8,000. Just keep pressing enter and you'll see that 6 years the loan is 10,108. So you can say that the question said how many weeks. I might convert it. Don't worry. I think it was a bit of a mistake. Just say how many years. 6 years is fine. All right, so let's have a look at this example. It says write down a recurrence relation model if 15,000 was borrowed at a simple interest rate of 3.8% per annum. So I can quickly highlight that. I know I'm in simple interest. This is my VO and they've given me the rate. So I go to my simple interest formula. I know that when I've got a recurrence relation, I have to write the VO and then I have to write this rule. okay? And I need to calculate what D is, so I'll find D, which is the rate over 100 times VO. So it's 3.8 over 100 times 15,000, and we get 5,700. So therefore, my answer when I write a recurrence relation will be VO is 15,000, and the Vn plus 1 is going to be Vn, and every time we're going to add 570. So there's my final, that would be my final answer. Okay, now we're going to look at, this is a different rule. We're still using rules, but now it's called the nth term. So what we're finding is, you know, if we're using our calculator and we're doing it recursively, meaning one after the other, if I ask you what's the 52nd term, that's going to get annoying. So we then create rules called the nth term rule to help us get to a further on spot a bit quicker. So this is not a recurrence rule. This is just another financial sort of rule. So if we look at, this is also, we're looking at, this is for simple interest. If I want to write a rule for the nth term for simple interest, this is the formula here that I'm going to use. Okay, so for example, if I wanted to find the value, you know, 52, what I'm going to do, see how this n would be 52, so the way I would find that would be VO plus 52 times the D, because in my example, n is 52. Okay, so that's what we're going to sort of do. So once again, if we have to set up this rule, the nth term rule, we will need to know what our initial value is, and we'll also need to calculate the D again, which is in our formula. All right, so this rule is just being written out here. This part is how you, if you look here, this is how you find D. So I've just written out the rule again, putting in those bits, so it doesn't matter what you use. Okay, so let's do this example. The following recurrence relation can be used to model simple interest. So here we go, we've got VO, and we've got, this is actually the D value. What is the principal of this investment? So we know principal is the VO, so what's that? It's pretty basic. It's what? We start off with 3,000, don't we? What is the interest rate per annum? So they actually want the R is the question. So what you've got to look at is we have the D value, and we know if we look at our formula for D, that's our formula for D. So if you have a look at it, I actually know what D is. So I could write 260 equals R over 100, and I know what VO is as well, don't I? It's 3,000. So the only thing I don't know in there is R, and that's what I'm trying to find out. So you can use solve on your calculator and comma R. And if we do that, we get the rate to be 8.7% per annum. Okay. All right, so now it says to write down the rule for the value of this investment after n years. So they want, this is them saying they want the nth rule. So we've got all the information, and here's the format for it. So if I was writing it out, the VO was, what was it actually? 3,000, yeah? So I write 3,000 plus, now our D was 260. We often write it like that. We put the number first. You could say n times 260, but we just normally we like to put the number first. So there's the rule for the nth term. Now, it says find when it's 15. So if n is 15, when I use that rule, what I do is I go 260 times 15. And then we get our answer of 6,900. Okay, that's all you're doing. You're just subbing in whatever n value you have to find into the formula. Now we're here when it says find when the value is 10,000. So if I've really got a formula for the value at any time is this. So if I don't know what n is, but I do know what the value at that time is, I can pop that into the equation, and once again you can see only n is what I don't know. So you can see I've done solve comma n. Now I find that the investment exceeds 10,000 at 26.9 years. You can't, even if it was 26.2, you can't round down because you won't make it at 26, will you? So you have to go over, so whatever's over it. So we'll say approximately after 27 years. So do you understand that? Even if it said 26.1, you have to get there. So it has to be the next year. We do round to a nice number, but you have to round. Now, all I'm going to get you to do is, you might need to take note of this because I've changed this. I want you to do 8C, questions 1 to 3. And then I want you to do 8D, 1 to 5. They're just the simple interest ones. So I'm trying to group it together so you're just doing simple interest questions.